DARPA's mission is to create innovative defense technologies. The agency's projects range from space-based missile shields to cyborg insects. At the same time, the internet, the first computer mouse, GPS, robot vacuum cleaners, and, for example, Siri were created. The uniqueness of DARPA is that by investing in the project, it does not seek to take a share in the capital, but only stimulate the development of technology and looks to where it will lead us. The first significant success of the agency was ARPANET, which laid the foundation of modern internet. In 1969, with the help of this computer network, the first message was transferred between computers in California and Stanford universities. Although then, only 2 of the 5 letters of the message managed to transfer. But on January 1st of 1983, the network became the first in the world to switch to data packet routing. As a routed protocol was developed by order of DARPA, the IP protocol, which is still basic for data transmission on the internet today. In 1964, Charles Rosen, head of the Stanford Research Institute Artificial Intelligence Center, proposed the creation of an intelligent automatic machine for the Advanced Research Department. The grant was approved, and it was assumed that the developed robot would be able to work as a scout or a patrol officer. This is how the Shaky robot came into being. According to the description, it could recognize its own environment, derive implicit facts from explicit ones, create plans, and recover from mistakes in a planned execution, and also understand orders written in plain English. The robot was equipped with video cameras, collision sensors, and a rangefinder. Communication with the control computer was carried out via radio. Shaky software architecture, computer vision, navigation, and planning techniques proved to be fundamental to robotics and web server development, video game creation, and Mars rovers. Autonomous robots, like self-driving vehicles, were one of the first and main goals of DARPA. To stimulate their development, the agency launched the Strategic Computing Initiative in the 1980s and allocated billions of dollars to it. The goal was to develop artificial intelligence techniques in multiple fields. Among the results, there are first autonomous cars and the first quadruple-legged walking robot by Boston Dynamics. Modern unmanned vehicles date back to a series of robotic races, which DARPA sponsored in the early 2000s to stimulate the development of this technology. And in 2004, out of all the applicants for the prize of $1 million, only one managed to pass a modest 12 kilometers of the planned 240-kilometer race. Later in 2005, the entire distance was able to be covered by 5 cars at once. In 2007, DARPA held another race, but this time with a prize of $2 million. The self-driving cars had to drive through the city, observing rules of the road, and interacting with each other at intersections. It was DARPA that sponsored the development of the first 4 Boston Dynamics Big Dog robots, presented in 2005. The robot, measuring 91 by 76 centimeters and weighing 110 kilograms, was able to move at speeds of 6.5 kilometers per hour and carry a load of 150 kilograms, as well as climbing a mountain with a slope at a 35-degree angle. The project cost DARPA $42 million, but was eventually closed because the robot was incredibly noisy. Nevertheless, Big Dog became the basis for the creation of both the Robot Spot and the Atlas robot. By the way, the robot was not the last development of Boston Dynamics for DARPA. All of the robots of the company, including those created for military purposes, we showed previously in a video. A link to that is now in the card above. Very unusual developments were and are among the agency's projects. For example, the Energy Autonomous Tactical Robot Program was aimed at creating robots that could feed on plants to independently replenish energy right where they would need to be working. Or the Engineering Living Materials Program, aimed at creating self-heating building materials with the development of 3D printing of organs and tissues. DARPA hopes to use similar technology to create hybrid materials that can form and support the growth of artificially created cells. These materials are able to be grown locally using already available resources. The Hybrid Insect Micro-Electro-Mechanical Systems Spy Beetle project in 2006 looked crazy. In 2009, the engineers even presented a prototype transmitter for cyborg insects. But judging by the fact that in 2018, the agency announced the beginning of the development of miniature robots to manage insects in the right quantities did not work. The new program SHRIMP for Short-Ranged Independent Micro-Robotic Platforms, and the robots developed within it will be related to the smallest types of these mechanisms, just the size of insects. The robots will be fast and maneuverable enough to jump, fly, and lift objects and perform terrain analysis. And these will not be the only bio-inspired robots from DARPA. Recently, the agency announced that next year it will present a completely finished robot worm, which will be able to tunnel at speeds of 10 centimeters per second. For the Project Underminer project, $2.5 million has already been allocated. The tunnels will be needed to quickly create tactical paths when fighting in cities and megacities. One of the important projects of DARPA was the Systems-Based Neurotechnology for Emerging Therapies program, designed to create implantation, diagnostic, and therapeutic closed-cycle systems for the treatment of psychoneurological diseases. Essentially, the program wants to create a brain implant that will help soldiers fight post-traumatic stress disorder and other problems. Interestingly enough, when DARPA began working on the neuro interfaces, it said it would create a chip that would allow the military to control combat robots and drones with only the power of thought. One way or another, the work on the brain chip continues. Another key area of DARPA's project is the creation of robotic pilots and artificial intelligence capable of controlling aircrafts and helicopters, including combat ones. Thus, at the end of the year, the final test of the Alias technology on Sikorsky UH-60M Black Hawk helicopters are able to be held. The test program will have remote and autonomous missions. Alias systems consist of a robotic pilot voice interface and software. In order to install Alias on any Black Hawk from the U.S. Army's fleet, only LiDAR and cameras are needed. The Artificial Intelligence Training System, which in the future will be able to take control of a combat aircraft and conduct close-air combat maneuvers developed by DARPA, is called the Air Combat Evolution. It was for its development that the recent neural network algorithms were tested with the Virtual Air Combat Alpha Dogfight trials. Remember, in the course of these, artificial intelligence managed to defeat a professional pilot of the U.S. Air Force with a crushing score of 5-0. The new neural network systems will have to control the fighter and flight faster and more efficiently than a man is capable of doing. It will be tested on a real plane in 2024. The preparation of the fighter for this event has already begun. Autonomous vehicle technology is of interest to DARPA, not only in the air but also on water. Just the other day, the agency announced it was ready to conclude contracts for supply of long-range uncrewed ships in 3 private companies within the framework of the Sea Train program. The goal is to overcome the range limit for sea drones by reducing wave resistance. After overcoming the necessary distance, the drones will separate to perform their tasks and on the way back, form back into a train. Also, at the expense of drones, the U.S. intends to soon increase the number of its fleets to 355 ships. This was recently announced by the U.S. Defense Secretary Mark Esper. He also reported on the demonstration of a prototype underwater drone Echo Voyager from Boeing and the Sea Hunter surface vehicle developed by DARPA. Apparently, they will join the ranks of the United States Navy. Another global goal of DARPA is the creation of swarm intelligence. That is the use of groups of robots to perform complex tasks. As a part of this project, researchers from Buffalo University recently received more than $300,000 to study the brain impulses and eye movements of gamers. The goal of this is to improve the organization and strategy of the autonomous air and ground robots through a new training method. These robots will be trained by an algorithm that should process the information collected by scientists, and it will help understand how gamers operate in some of the unexpected situations, what they pay attention to, and how they operate, and what these actions lead to. The research of robots is conducted by DARPA in 2 other directions. The first is the Offset Project, the development of software that will combine various ground robots and unmanned aircrafts into one group. The robots in the group must be able to solve one or more tasks together using more than 100 tactical options. The second direction is the Squad X project. It involves the introduction of drones, robots, and sensors on the battlefield to maximize a soldier's awareness of their current situation as well as other tasks. DARPA has already tested the program through a week-long exercise, during which United States Marines used drones and robots to coordinate their movements and detect potential threats in the field. The information from the sensors was processed by artificial intelligence systems and only then passed on to the military. This is probably how battle scenarios of the future are going to look. It's impossible not to mention that thanks to DARPA, the whole world was able to enjoy a spectacle of human-like robot races at the DARPA Robotics Challenge. Videos of the epic robot fails of various designs quickly became a hit on YouTube. And although it was very funny, we shouldn't forget to thank these types of events. Robotics are developing, and today we can see the results of this with smart robots like Atlas. Subscribe to the channel, like the video, and share this video with friends, and definitely do not miss any new releases from Pro Robots. Coming in at 5th place, China's Jari USV, a 20-ton impact robot vehicle designed for anti-submarine warfare, striking ground targets and engaging air targets. Tests of the robots began last year. It is 15 meters long and has a displacement of 20 tons. The Jari USV is capable of speeds of up to 42 knots and has a cruising range of 1,000 kilometers. The Jari USV is equipped with an electro-optical sensor on top of the superstructure, phased smart antenna, and sonar. Depending on the combat mission, the boat can be armed with an 8-cell vertical launcher, torpedo launcher, missile launcher, and a remotely controlled combat module with a 30mm automatic gun. The robot can operate in fully autonomous mode or be controlled remotely from the command ship. Here in 4th place is Ghost Robotics' K9 Dog Robot. The US Army began introducing robots. Ghost Robotics Vision 60, nicknamed K9, is already patrolling military bases in Florida to enhance security and surveillance. The 325th Security Forces Squadron is in charge of base security, and they said that the robots are weatherproof, four-legged, unmanned patrol drones with two-way communications and high-tech sensors that cost about $100,000. By February of 2021, 4 robo-dogs will be deployed around the base perimeter, where they can either move autonomously or be controlled by an operator through a virtual reality headset. The robots are designed for stability on any terrain and have reduced mechanical complexity, reducing costs but increasing reliability and maneuverability. Operating time on one charge is 7 hours, and although the robot dogs don't bite, a safety mechanism will be triggered if you try to damage them, and that mechanism is not yet known as they have not disclosed it. The K9s will be an extra set of eyes and ears when processing large amounts of data and strategic points throughout the Air Force Base. Number 3. An entire family of armed robot tanks is also planned to be adopted by the US Army. The project is called Mission Enabler, Technologies Demonstrator, and provides for the creation of combat robots in 3 classes at once, in light, medium, and heavy. They're capable of shooting, interfering with enemy communications, putting smoke screens in front of soldiers moving forward, and performing other dangerous combat tasks. The smallest vehicle, the Robotic Combat Vehicle Light, or RCVL, will be a wheeled vehicle weighing less than 10 tons and armed with light but powerful weapons such as the Javelin anti-tank missile launcher. The RCV Medium, with nearly the same dimensions, will be twice as heavy to accommodate heavier weapons, armor, and tracked gear. The robot will be equipped with a medium cannon, probably the 30 to 40mm range, or several anti-tank guided missiles. And last in this group is the Robotic Combat Vehicle Heavy, weighing up to 30 tons and will be the main battle tank without a crew. It will be armed with large-caliber direct-fire guns capable of destroying tanks such as the Chinese Type 99 and the Russian T-14 Armata. For now, the robots will be controlled remotely by an operator without the use of radar to reduce the machine's visibility. But in the future, control will be transferred to artificial intelligence, and work in this direction is actively being carried out by the US today. Here in 2nd place, robot tanks are acting on the principle of the Wolfpack with German company Rheinmetall, which released an animation the other day demonstrating how they operate. The swarm of robotic tanks moves and identifies targets using artificial intelligence, while the decision to fire is made by an operator. The Rheinmetall swarm consists of a squad of armed reconnaissance vehicles and a camera system with a remote-controlled machine gun, which are inserted to the combat area by helicopter. The robots can also carry multiple launchers to launch exploding kamikaze drones. To back up the animation, Rheinmetall unveiled a new reconnaissance combat module for its Mission Master robot platform. The module's payload is mounted on a 3.5-meter-long extendable mast with tilt mechanism that allows the vehicle to use the system on the move or from flaps. The stuffing consists of 2 digital radars, a 360-degree camera, a laser rangefinder, a designator, and a Field Ranger light combat system. The Mission Master weighs 1,100 kilograms including its batteries and carries up to 600 kilograms of payload. The platform is an amphibious vehicle capable of swimming at 5 kilometers per hour. The robot can operate for 8 hours or travel for 140 to 160 kilometers at 20 kilometers per hour with fully charged batteries. However, in recent operational tests, the vehicle lasted more than 24 hours without recharging because most of the time the power consumption rarely reaches peak levels. Friends, while we're here, don't forget to subscribe to the channel. It really motivates us to make even more interesting releases. And here we are in first place with the Tempest Future Fighter. The Tempest Future Fighter is a next-generation air combat system that should be ready by 2035. It's being developed by the UK Ministry of Defence in conjunction with a host of technology companies and institutes. The 6th-generation fighter will incorporate several new technologies, including invisibility, direct energy weapons, and hypersonic weapons. Tempest, with elements of artificial intelligence, will be able to fly autonomously and use drone swarm technology to control them. Another tech being developed in Tempest is the ability to interact on the battlefield, exchanging sensor data and messages to coordinate an attack or defend with other robots. Tempest will have an adaptive cycle engine and a virtual cockpit displayed on the pilot-operator headset. A generator has also been developed for the aircraft, providing unprecedented levels of electricity. A key feature of the drone will be the radar technology with data processing capacity equivalent to downloading 9 hours of HD video per second or all the internet traffic of a major city. Today, the military is deciding whether the weapons of the future should attack independently or whether the control should still belong to humans. For the military, this is not a question of ethics, but speed of response and thus survival in future wars. Who do you think should be left with the decision to destroy targets? Let us know down in the comments. Subscribe to the Pro Robots channel and be notified of any new releases. Canadian company HyperTealth Biotechnology already produces camouflage uniforms for the military all around the world. But recently, it has patented a new material, quantum stealth, which can be called a real invisible cloak. The developed quantum stealth technology allows to disguise Army soldiers, its tanks, planes, and ships. The material does not require a power source, it is thin, inexpensive, and allows everything that is behind it to disappear. The technology is based on redirecting light around the target, and it directs not only light in the visible spectrum, but also ultraviolet, infrared, or shortwave infrared light. The U.S. National Intelligence Agency's Sediment Program provides a fully integrated intelligence system that can coordinate the position of satellites and control the course of the hostilities. The geospatial intelligence being developed, which is likely to be deployed without informing the general public, is an omnivorous analytical tool capable of absorbing any data, analyzing both past and future. By collecting not just satellite images, but by marking the right images on them with a date and geolocation. Sentient catalogs normal patterns, detects anomalies, and helps predict and stimulate potential enemy actions by pre-directing satellites to where the most interesting events will take place. As well as developing increasingly sophisticated drones, engineers are developing robotic pilots that can replace humans in conventional aircrafts on the battlefield. The robot, developed as part of a collaboration between the U.S. Air Force Research and Development Laboratory and Design Technologies Incorporated, successfully completed a 2-hour test flight. The robo-pilot can easily be landed or pulled out of the cockpit of any aircraft without upgrading it. And while the robot needs hundreds of hours of training before it can be implemented, it can replace real pilots on a number of missions in the coming years. In the Army of the future, machines will not only replace people, they will merge with them. According to the declassified report by the U.S. Department of Defense, Soldier-Cyborg 2050, Merger of Man and Machine and Implications for the Future, the military plans to implement what has always been considered to be science fiction by 2050. The report's summary outlines 4 main areas that may have been recognized as real: improvised vision, visualization and awareness, hearing enhancement, and recovery and programmable muscle control using an optogenic sensory body, and direct neural enhancement of the human brain for two-way data transmission. In other words, engineers must connect soldier minds to computers so that warlords can instantly transmit new information and allow soldiers to control their drone machines with the power of thought. The researchers noted that cyborgization is likely to be used in civil society as well over the next 30 years. 6 teams of researchers are already working on technology to control military robots and swarms of drones by force of thought on behalf of the Pentagon. DARPA Neurological Neurotechnology was launched in March of 2018 in hopes of developing a brain-computer interface that does not require surgical implantation. Today, 6 teams are trying to solve this problem from different angles. For example, a team from Carnegie Mellon University is checking to see if electrical and ultrasonic signals can support a non-invasive interface, while a team from Johns Hopkins University is exploring the use of near-infrared light. Supervision, without introducing cyborg elements, is also being actively worked on. The US military is developing night vision goggles whose capabilities are enhanced by augmented reality. And it's not just a built-in compass and a sighting system. The integrated visual amplification system will enhance soldiers' capabilities in combat by providing them with new ways to communicate and coordinate with each other. Based on a version of the Microsoft HoloLens headset, the system will include a number of features that look as if they were extracted from a video game. For example, soldiers will be able to pinpoint specific locations on a map, and then beacons will show them where that location is when they look around. They will also be able to see glowing outlines of other soldiers so that they will always know where everyone is, even if they can't see them directly. Another area of vision expansion includes the development of a smart contact lens. For example, the French engineering school IMT Atlantic is developing a first autonomous contact lens with a flexible graphene-based micro battery. The latter is capable of powering the built-in electronics for several hours to reproduce and transmit visual information wirelessly. DARPA and Microsoft are ready to invest in the project. Clinical trials of the lens should begin soon. Development of the latest weapons is also in full swing. For example, engineers from the Chinese Academy of Sciences have created a portable sound cannon designed to disperse the crowd. All the owner has to do is point the device at the crowd and shoot. Focused sound waves will cause painful vibrations to the target's eardrum, eyeballs, and brain. The cannon runs on inert gas. When the gas heats up, its particles start to vibrate and the device makes a deep, monotonous sound. The difference in this current development and another sound weapon in compactness is instead of a bulky machine on a vehicle, this device is comparable in size to a conventional rifle. The Pentagon is working on a weapon that uses lasers and plasma to transmit sound files, including human speech, to individuals over long distances. Laser balloons can be dropped from military aircrafts or other vehicles to issue instructions or disperse crowds of protesters. The Lockheed Martin and Dynetics team of engineers also received a $130 million contract to supply 100 kilowatt laser weapons to the United States Army. The HEL-TVD High Energy Laser Tactical Machine is to be ready by 2022. The system is designed to protect against missiles, drones, and artillery. The power supply and the temperature control system for the new weapon will be provided by Rolls-Royce. The system is planned to be installed on a medium-sized military truck. Estonia has created and developed a tank robot submachine gun from Terminatra. The robotic tank, called Themis, is equipped with a 12.7 machine gun and a 40th automatic grenade launcher. The Themis is a ground-based combat robot that can be operated from a distance beyond line of sight. A small team can direct the tank towards targets that its software has already detected and tracked. The tank can be controlled from a distance of up to 2.5 kilometers. The armored robot can track multiple potential targets simultaneously, but cannot pull the trigger yet. the decision to destroy must be made by the operator. Israel is also implementing its vision for tanks of the future. The advanced program of Carmel armored combat vehicles includes the development of advanced equipment by 3 military contractors: Elbit, Rafael, and Israel Aerospace Industries. Each company has its own vision. The Elbit version includes helmets which display images from cameras and sensors on the outer side of the tank. The Rafael version has a revolutionary panoramic design. And in the Israel Aerospace Industries version of the tank, the soldiers used a joystick similar to an Xbox to control the military vehicle. Russia has its own developments for the Army of the future. For example, the C-70, a heavy strike drone hunter capable of working in tandem with the Su-57 and attacking areas protected by air defense. The drone, which weighs about 20 tons and is equipped with radar reduction technologies, an automatic control system, an internal satellite navigation system, and a system for monitoring diagnostics of onboard equipment. The Hunter is capable of speeds up to 1,400 kilometers per hour at low altitudes, climbing up to 18 kilometers in the sky and making flights with a range of 6 kilometers. The price of the drone is expected to be $14 million. The armament is not yet known. Work is also underway to develop the 2M39 Poseidon, a large, self-propelled submarine with a nuclear power plant that provides vehicles with unlimited range. The main purpose is to deliver a megaton-class payload to coastal and any marine fixed or low-mobility objects with known coordinates. The vehicle, with a stroke depth of more than 1 kilometer, is supposed to be equipped with an autonomous internal control system with the capabilities of command correction, route correction on the hydroacoustic map of the sea bottom relief, as well as according to special hydroacoustic beacons. Let us know down in the comments, which military technology do you want to know about? Don't forget to subscribe to our channel and stay up to date on the latest high-tech news. The super soldiers of the future must be stronger and faster, not only physically, but also have enhanced perception and thinking. There are 2 ways to achieve this. The first is by equipping the soldier with special equipment, while the second involves the implantation of invasive chips into the body and genetic engineering. Let's start with the equipment. For example, the Pentagon has long been invested in the development of Integrated Visual Augmentation System, or IVAS, combat goggles. Based on Microsoft technology, the goggles can project 3-dimensional holographic maps in real time, allowing soldiers to know the terrain and see in all conditions because infrared, thermal, and night vision are integrated. In addition, the technology allows soldiers to know the exact position of their team members, distinguish military from civilian, and see through equipment such as tanks coming ahead of infantry. The latter is realized by transmitting data from the external cameras of combat equipment directly to the glasses display. The gadget is a head-worn hoop with tinted lenses in the front of the eyes with a wave-like prismatic structure, which refract and send images from the micro-displays on the sides to the user's eyes. Unlike most other virtual, augmented, or mixed reality devices, the Microsoft HoloLens-based device is self-contained and does not require a PC connection. VAS also reported to link some of the neurological processes of human vision to the software. This, for example, allows the human eye to perceive the depth of a picture in a new way or to make better use of peripheral vision. The system also determines by itself what the eye focuses on and creates a 3-dimensional image of the object, supplementing it with parts invisible to humans. Japan has its own ballistic DevTac Ronin Kevlar helmet. The helmet weighs 200 grams, not including accessories, and is protected by 7mm thick Kevlar plates. It's equipped with non-fogging heavy-duty lenses and a ventilation system. The gadget is able to withstand shots from a 5.45mm pistol. Additionally, it's equipped with infrared sights, night vision devices, and GPS transmitters. There's an interactive display, which transmits data about the area and recognizes the enemy by a code, friend or foe. But if a soldier has to see everything, it's desirable that no one should see him. And there are developments for this. For example, the European Defense Agency is funding a project to develop style or smart textiles in defense. The fabric has different camouflage options that adapt to a soldier's static or moving posture. It can detect and inform the soldier of the presence of dangerous agents, protecting the soldier from fire, water, and mosquitoes. In addition, the fabric can regulate its temperature, adapting to the environment around it. And finally, the textile can monitor vital signs and send them to the soldier's smartphone or operations center nearby. And Hyperstealth Biotechnology has developed an invisible cloak for the military. The light-absorbing material Quantum Stealth absorbs ultraviolet, infrared, and thermal radiation, refracting light and making people or equipment invisible, including for guidance systems. From a certain angle, the fabric can make even a building invisible. The material is very light and very thin and doesn't require a power source. Powerful sensors are also being developed for the military that can detect threats on a molecular level, whether they are explosive materials, particles from a potentially dangerous object, or a deadly virus. The sensors can be used both to detect improvised explosive devices on the road and to diagnose an infection in the soldier's wound. The technology is currently being tested. In addition to individual gadgets, full suits are also being developed for super soldiers. For example, the American Future Soldier System, which includes a bulletproof exoskeleton, body armor, interactive helmet, and weapons. The system consists of modules that can be combined in any combination. It's lightweight, easy to operate. A special module monitors the soldier's physical condition and helps navigate the terrain. The system also monitors weather conditions and regulates temperature with cooling or heating, transmitting data over a distance, and has a built-in battery for recharging. Special devices on the legs allow it to increase the speed of movement. A Sotnik combat suit is being developed in Russia. The heated suit, made of high-strength and lightweight polyethylene fiber, will be tailored to the fighter's figure due to the elasticity of the material. It will not hinder the movements, and it will allow you to take additional equipment. At the same time, the protection class of the Sotnik will allow to stop a fragment flying with a speed of up to 670 milliseconds and to dampen the shock impulse due to the use of special shock-absorbing equipment. Robotic systems, exoskeletons, and combat drones, including strike drones, will be integrated into the new generation of Army equipment. Rosetech also recently unveiled a military exoskeleton. The main part of the exoskeleton is hidden under the outfit and relieves the combatant's musculoskeletal system. This innovative equipment can be used not only for military purposes, but also in medicine and industry. It's designed to carry up to 60 kilograms of cargo while weighing no more than 6 kilograms. Externally, only the part with hydraulics located on the soldier's legs is visible. Another noteworthy function of the new technology was the ability to fix the position of the joints, so a person could stay in one position for a long time without getting tired. In Canada, PowerWalk exoskeletal power generators are being developed. They're attached to the legs and produce 10 to 12 watts of current while walking. That's enough to charge 4 smartphones. In addition, the PowerWalk is designed to help reduce strain on the fighter's legs and joints while jumping over obstacles, and also to give up batteries weighing up to 7 to 9 kilograms. The Human Universal Load Carrier is a hydraulically powered exoskeleton designed to support soldiers on the battlefield, allowing them to carry heavy loads for long periods of time without fatigue or risk of injury. The exoskeleton allows the wearer to maintain full range of motion and also is compatible with other technology such as armor, heating systems, and various special devices. It's already been assumed that the super soldiers of the future will also be able to fly. Thus, DARPA has launched a competition to create flying suits for the military. They will be used to move people and cargo dropped from the air, and unlike existing models, the military development will be much lighter, quieter, and inconspicuous. The British are also testing a jetpack, the Daedalus, based on the Gravity Jet suit by Gravity Industries. The device is capable of speeds of over 88 kilometers per hour and is designed for disembarkation. A significant disadvantage so far is the noisiness of the development. All of this can be seen in the news one way or another, but developments in the field of invasive chips and genetic engineering are kept a closely guarded secret, although no one doubts that they are being conducted in China, the United States, and a number of European countries. In addition to ethical considerations, scientists are confused by the fact that the results of experiments with human DNA cannot be predicted to the end. Artificially enhancing the stamina and strength of soldiers does not guarantee their loyalty and patriotism. And implementing chips that give superpowers in one area or another should be reversible with no health consequences, so that they can be extracted when the soldiers leave the military. Super soldiers may seem like science fiction for now, but no more so than, for example, drones equipped with neuromorphic chips that mimic the human brain, which are already being developed. Or man-made lightning bolts, where the electric charges generated would be sent long distances. Their power would be comparable to that of real lightning. The technology is based on the idea of a laser corridor with a significant difference in electric potentials. Accordingly, the electric discharge passes through the formed corridor with minimal resistance. And there's also a storm generator project that sends high-speed shockwaves into the air. If you enjoyed this and you want to be aware of more technology just like it, subscribe to the Pro Robot channel while you're here, and don't miss any new episodes. What will the wars of the future look like? Today, it is safe to say that the first thing the enemy will see on the battlefield are swarms of killer drones, controlled by the military or fully autonomous. Why kamikaze drones are the future of warfare and who is already creating and using them, we will tell you in this issue. The first unmanned systems, land, sea, and air, were actually teleoperated bombs. The most famous is the German Missile project, in which conventional aircraft were converted into drones packed with explosives and delivered to the target by an aircraft carrier. During the Cold War, reconnaissance drones were created by many countries, including Israel, the United States, and the Soviet Union. The Soviet Union's Tupolev Design Bureau developed the Tu-141 reusable reconnaissance drone in the 1970s. Equipped with photo and infrared reconnaissance, the drone could fly at a cruising speed of 1,000 kilometers per hour for distances reaching up to 1,000 kilometers, and landing using a parachute system located in the tail section. But drones began to play a very big role in military affairs just recently. The first recorded cases of mass drone attacks were in Syria in 2018. In 2019, there was a massive drone attack on Saudi Aramco's state oil refineries in Abqaiq and Khurais. In 2020, in Nagorno-Karabakh, drones including kamikaze drones showed the world that the coordinated use of armed drones and barraging munitions against tanks and air defense systems could dramatically change the course of the conflict. Why are kamikaze drones the future of war? First, killer drones can operate autonomously, which means that continuous communication with the machine, which can be detected or jammed, is no longer necessary. For example, the Israeli Harpy drone, which can be used for both reconnaissance and as a kamikaze strike drone. Its own radar and navigation system allow it to act according to a pre-written program written by the operator or search for targets by radar itself. The radar allows the drone to quickly locate enemy air defense systems by their emissions. The Harpy cannot be jammed by REBs, and it is quite difficult to target for air defense, as the composite hull does not allow it to be detected at long ranges. Second, even kamikaze drones can be reusable. For example, the Hero, which was a further development of the Harpy drone concept. Using a visual target classification system borrowed from the Spike missile, these kamikaze drones can detect targets visually without using their radar and identify target types by comparing pictures to a three-dimensional library. This allows the drones to be fully autonomous. The operator can literally only specify the square of the target search, after which the drone will automatically leave the launcher and fly to the specified square to look for its targets. If no targets are found, the drone will return to the square specified by the operator and land by parachute. Then it can be used again and again after refueling. This is fundamentally different from earlier versions of kamikaze drones, which, for each flight, was their last. And third, drones have learned to operate in swarms, which multiplies their value, capabilities, and destructive power. Swarmed drones are capable of conducting coordinated attacks with minimal operator involvement. Takeoff, formation, and formation holding, route keeping, return to base, and landing are accomplished autonomously. However, some drones are capable of selecting and engaging targets independently, alone or in coordination with other group members. Swarms are not necessarily homogeneous. A heterogeneous swarm includes different types of vehicles with different weapons on board. Kamikaze drones are produced all over the world. They include the Turkish Kargu, which create decoys for enemy air defenses while carefully scanning the terrain. The Chinese Zhuhai Xian's Blowfish A2, capable of speeds of up to 130 km per hour, and carry onboard 60mm mines as well as 40mm grenade launchers. By the way, the new generation of drone A3s is capable of carrying several types of machine guns on board, and according to the manufacturer, there are many orders for these drones. Russia is also interested in creating kamikaze drones. For example, the Kalashnikov concern is developing the KUB and Lancet, which are remotely controlled projectiles that explode when they reach their targets. According to the manufacturer, KUB is capable of reaching a speed of 130 km per hour, flying for half an hour, and hitting the target regardless of its stealth and terrain. Additionally, it is planned to equip the Marker combat robotic platform with the kamikaze drones. Several types of smaller kamikaze drones, such as the Sky Striker, Harop, Orbiter 1K, and Orbiter 3 hover munitions, have been used in Nagorno-Karabakh. Some are guided by air defense radar, while others rely on optical, infrared, and other sensors. The Orbiter 3, for example, can breeze for 6 to 8 hours and weighs only 3 kilograms. The Sky Striker is heavier. Its warhead can be 10 kilograms, but the value of these drones is not in their power, but in their price. One Sky Striker drone can cost less than $1 million, according to Defense News. At the same time, kamikaze drones are usually equipped with advanced navigation and targeting systems, capable of aiming and keeping in their sights, maneuvering towards its target at speeds of up to 550 km per hour. In other words, such a drone is capable of destroying a modern tank or missile system worth much more than the cost of the drone itself. To launch these swarming kamikaze drones, China demonstrated a multi-barrel launcher. The combat vehicle was created on the chassis of a 3-axle version of the Dongfeng Warrior armored vehicle. Containers with UAVs are in special protected compartments that raise before use. In total, this system can engage 48 barraging munitions. So, why are kamikaze drones so dangerous? Although such vehicles are not currently classified as lethal autonomous systems, since they are supposed to involve an operator, it is virtually impossible to verify this. Technically, a barraging munition can be fully autonomous and perform a mission without the participation of the operator. So, we can consider this to be a prototype of autonomous robotic killers. But the main thing is that modern air defenses are designed for classic targets like planes, helicopters, or tactical missiles. They may not observe drones at all, especially if they fly low or they're seen too late. Additionally, the target system of the complex might not be designed for hitting such targets. Add to this the fact that the cost of an air defense projectile is hundreds or even thousands of times higher than that of a kamikaze drone. The only solution here is a special anti-drone defense system. We will see active development of these systems in the coming years, along with the development of the kamikaze drones themselves and impact drones as well. Want to know more? Subscribe to the Pro Robot channel and let us know down in the comments what questions are left regarding kamikaze drones.
Today, more than 100 countries are developing military drones, constantly innovating to make them faster, more powerful, and smarter. Drones are used for reconnaissance, surveillance, target detection, munitions delivery, and enemy strikes. The vehicle can fly around autonomously or be operated by an operator, return to the base, or play the role of a kamikaze. See an overview of the best military drones and trends in the development of combat drones in today's one episode. Major players in the drone market are the US, China, and Russia, Turkey, and Israel. The most advanced drones being developed today should include automatic takeoff and landing capabilities, require a minimum of maintenance personnel, be equipped with satellite communications, and ideally be able to fly above ground and water, but that is not enough. New technologies such as Raytheon Technologies are working for DARPA in allowing drones to come together to fly autonomous swarms. The operator does not need to control each drone separately, but instead directs the raid through the tablet using speech and gestures. Northrop Grumman also works on autonomous drones that are able to exchange information between themselves and the manned vehicle. The company relies on continuous miniaturization of sensors, reduced payload cost, and the use of drone swarms and artificial intelligence technologies. But moreover, smart algorithms are used not only to detect and recognize targets, but also diagnose the problems in the drone itself, which reduces the cost of operating it. However, at the same time, the issue of cybersecurity is becoming increasingly acute. So which military drones are considered the most advanced in the world today? Turkish Aerospace Industries Aksengur is classified as a medium-altitude unmanned aerial vehicle with a long service life. It is built on the basis of Thai Anka series drones, but has a greater payload capacity and is designed for long-term surveillance, radio reconnaissance, naval patrols, and use as a combat unmanned aerial vehicle. Since 2021, the drone has been used by the Turkish Army. Aksengur can carry up to 750 kilograms payload, accelerate to a speed of 250 kilometers per hour, and travel up to 6,500 kilometers while in the air up for 60 hours. It can be armed with various combinations of rockets, bombs, and torpedoes for naval patrols. It's also known that during the test, the drone carried a bomb of the Mk-82 series with a set of guidance plus Tiber 250 kilograms, which struck the target at a distance of 30 kilometers. The MQ-20 Avenger drone, formerly called the Predator-C, is primarily used for the United States Air Force and is a multi-purpose vehicle of a new generation whose design and speed increase in resilience in high-threat situations. The drone is designed for armored intelligence and rapid response. The Avenger is equipped with a turbofan engine and for stealth having an internal weapon storage and an S-shaped exhaust with a channel to reduce radar and thermal signatures. It can transport almost 3 tons of ammunition, including anti-tank missiles and laser-guided bombs. The MQ-20 Avenger also uses the F-35 Lightning's optoelectronic guidance system to fire on the enemy. The Hermes 900 drone from Ebit Systems is used primarily in the Israeli Air Force. Unmanned aerial vehicles are equipped with satellite communication systems, optical electronic monitoring systems, onboard radar with aperture synthesizing, radar indicating stations for moving targets, infrared sensors, laser target indicators, a laser designator distance meter, electronic warfare systems, and a data exchange system that enables real-time image transmission to a control center. The drone has a modular design that allows you to quickly change to the main components and sensors of the device for specific purposes. Control with two-way data transmission systems is also carried out by satellite and an operator from the ground station. Its stated purpose is surveillance, patrolling, and reconnaissance. However, it is optional to equip the drone with shock systems or, for example, an inflatable raft for rescue operations at sea. Another Israeli drone is the Israeli Aerospace Industries Heron TP, which is mainly used by the Israeli Defense Forces, but is also one of the best-selling military drones in the world. A medium-altitude, long-duration multi-purpose drone can carry fire controls and impact systems. Also included in the onboard equipment and tracking and target detection systems is an optical, infrared, and radio bands, satellite navigation, and a system that's capable of allowing the drone to refuel in the air. Also, according to the information agency Exuna, Heron TP can make an autonomous takeoff and landing, for example, in conditions of poor visibility and fog. The Chinese drone Hongdu GJ-11 Sharp Sword from the Hongdu Aviation Industry Group is primarily used by the Chinese People's Liberation Army Air Force. This is a low-visibility combat drone that's almost certainly unknown. It's reported to be equipped with a large internal weapon compartment system that's capable of delivering laser-guided munitions. The drone of the design of the Flying Wing with a scale of 14 meters is equipped with one turbofan engine and a low-visibility jet nozzle. The exact purpose of the drone is currently unknown, but it's likely to perform aerial reconnaissance and surveillance of opposing forces. Next up, the CASC Rainbow, or CH-5 by China Aerospace Science and Technology Corporation. It's also used mainly with China. It's a new medium-altitude reconnaissance and strike drone that can carry up to 16 air-to-ground or other high-precision munitions with a total mass of up to 900 kilograms. The wingspan is currently 21 meters and the maximum speed is 400 kilometers per hour. Without refueling it, it can stay in the air for up to 60 hours. Rainbow 5 is equipped with a new heavy fuel engine that increases its endurance and range. Thanks to a common data link, it can interact with CH-3 and CH-4 drones. It's planned to extend its range up to 20,000 kilometers in the future, and the drone was designed with an analog to the American MQ-9 Reaper. The General Atomics Aeronautical Systems MQ-9 Reaper, or Predator B, is used not only by the United States Air Force, but also the United States Customs and Border Protection Service. The drone is positioned as the world's first killer hunter, with remote and high-altitude surveillance capabilities, although it is not the most technologically advanced combat drone available today. With many upgrades and millions of flying hours behind it, it can take off at 14 kilometers and be airborne for up to 30 hours. Cruise speed is at 280 to 310 kilometers per hour at maximum of up to 480 kilometers per hour. The drone is able to lift up sky cargo weighing 4.7 tons, recognize and track targets, and count license plates from a distance of up to 3 kilometers from a car. Response time received from the operator is 1.5 seconds. Armed with the Reaper anti-tank missile and guided bombs, this drone can carry up to 14 air-to-ground missiles. Another Chinese military drone is the Kaigwing Loon 2 of the Chengdao Aircraft Industry Group, used by the Chinese People's Liberation Army Air Force. Designated JG-2, the unmanned aerial vehicle can be operated remotely or fly autonomously. It's believed that it's currently being used as a platform for surveillance, aerial reconnaissance, and high-precision attacks. Wing Loon 2 is equipped with satellite communications and is capable of long-range strikes, carrying air-to-air weapon systems or up to 200 kilograms of laser-guided bombs. According to the manufacturer, the autonomous operation time is about 32 hours, with ranges of 4,000 kilometers and maximum speeds of 370 kilometers per hour. The X-47B drone from Northrop Grumman is a demonstration combat unmanned aerial vehicle designed for sea operations with the ability to take off and land on aircraft carriers. The aircraft is a tailless jet aircraft with a mixed wing, capable of semi-autonomous flight and refueling in the air. In April of 2015, the X-47B performed the first ever fully automatic refueling procedure, but then the drone program was shut down because of the cost. However, the 2 available copies of the drone became museum exhibits at the U.S. Air Force Base Davis-Monthan in Arizona, retaining their equipment completely. And in case the program decides to resume, at the time of the preservation, the drones did not have 20% of their flight life. The Russian drone S-70 Hunter is a long-range unmanned combat drone developed by Sukhoi Company. The drone can carry out single combat missions, including autonomous modes, as well as cooperate with the Russian aircraft of the 5th generation, such as the Su-57. It's a heavy invisible drone of the 6th generation weighing about 22 tons, which can be equipped with ground-to-air rockets, controllable and unguided aircraft bombs, both installed in the inner compartment and attached to external suspension. The maximum speed of the vehicle is about 1,000 kilometers per hour. Combat load is 6 tons with the maximum altitude of 18 kilometers and a range of 6,000 kilometers. And the drone possesses the design of flying wings, and on its board there are information control systems, radar complexes, automatic control systems, systems of control and diagnostics of onboard equipment, as well as inertial satellite navigation systems. The radar system and communication systems allow the S-70 to be used to expand the radar field of other combat aircraft and to provide remote targeting. In addition to drones today, kamikaze drones and barrage munitions are being actively developed, more about which we've told you in the release you can find here in the tip. In general, while drone strikes keep pilots and soldiers off the battlefield, this separation can cause problems, and drone use is controversial. According to groups such as the Bureau of Investigative Journalism and Amnesty International, drone strikes have killed hundreds, if not thousands, of civilians in Afghanistan, Pakistan, Somalia, Yemen, and Iraq over the past 2 decades. While the newest drones are becoming more autonomous, the question of the ethics of passing the drone strike decision to artificial intelligence systems is still unanswered. What do you think is worse, artificial intelligence or human decision-making? Write in the comments below. Subscribe to the channel and like this video. Don't miss any new episodes from the world of robotics and high tech. Future Combat Systems is a lightweight and impact-resistant combat suit for the U.S. Army. It includes a bulletproof exoskeleton, body armor, interactive helmets, and weapons. The system consists of modules that can be combined in any combination. The suit also has a separate module that monitors the soldier's physical condition and helps him navigate terrain. The system monitors weather conditions and regulates temperature with cooling or heating, transmits data over a distance, and has a built-in battery for recharging. Special devices on the legs allow to increase the speed of movement. Russia has its own analog of such equipment called the Ratnik 3. It includes an exoskeleton, an interactive helmet, and a module for assessing psychological parameters. The equipment is made of fireproof, water-resistant, and bulletproof material. The lower part of the body is reinforced with titanium plates. Protective goggles with interactive displays show terrain data, thermal imaging measurements, and biological parameters. With the help of embedded modules, all soldiers receive a friend or foe alert and commanders track wounded and killed. In the future, the helmet is to be used equipped with a laser beam weapon guidance system and a smart tissue that prevents hypothermia and overheating. Also, several miniature drones for reconnaissance. In total, the suit will be able to carry up to 100 kilograms of supplies and travel at speeds of up to 20 kilometers per hour. The Ratnik 3 is also the successor to the current Ratnik 2 outfit, but even before it's introduced, it could be replaced by the Sotnik suit, whose main difference will be the use of lighter and more flexible materials. Higher capacity military uniforms are also being developed in Great Britain. It's called Future Integrated Soldier Technology, and its purpose is to integrate a modular system of all the equipment, weapons, sighting systems, and radios which carries or uses an individual soldier to increase their overall effectiveness on the battlefield. A key component of the project was the Bowman Communication System, which provides secure communications with ground forces, allowing for simultaneous voice and data communications, and has built-in GPS equipment. It also allows visual information to be sent directly from personal cameras. Future integrated soldier technology should increase situational awareness for the firing squad and local commanders, enhance their combat power with new NLAW and Javelin anti-tank weapon systems, and simplify route planning. This soldier's French outfit is called the Feline. The battle suit is very different from the American and British types. The uniform is very similar to the Russian Ratnik 3. It has a visual guidance system to help soldiers attack even difficult situations. The Feline has a rigid base and is equipped with an exoskeleton that provides ankles and knees as well as sweat-diverting systems. The material used for the uniform is much closer to the non-technological type as it can repel water and insects. The headgear is a Spectra helmet equipped with a real-time positioning and information system, as well as light amplifiers for night vision. Power sources consist of 2 rechargeable lithium-ion batteries. But the heaviest and toughest is the German IDZ-ES multi-purpose combat suit. This outfit has something unique, a navigation and control system that collects information about the position and location of the nearest enemy. The suit also has fully integrated and compatible with the combat control and communication systems of the Puma and Boxer BMPs. The SK-1 fabric vest, with built-in ventilation systems, provides protection against pistol bullets up to 9mm. OpsCore 1,328-gram fast ballistic helmet is designed to fit a variety of attachments, such as lights and night vision goggles. The fast ballistic helmet also has a display that allows each soldier to see with one eye the positions of all troops in their squad. Many related technologies are also being developed for soldiers in armies around the world. The US Army, for example, already uses FLIR Black Hornet 3. It's a pocket-sized drone that will perform surveillance and reconnaissance in combat. The drones come in pairs, one for daylight and one for night vision. The drones are 15 centimeters long and can fit on a soldier's belt. The Army hopes to equip every soldier with drones in the future. The Russian military is developing the D-14 Shellist parachute system, which will allow soldiers to access their weapons and begin firing immediately after they jump out of an aircraft. The D-14 Shellist is created specifically for landing in Ratnik outfit and is designed to be airborne from 1,200 to 8,000 meters at speeds of up to 350 kilometers per hour. The delay in opening of the main parachute will be up to 10 seconds with the use of stabilizing parachutes. The maximum flight weight will be 190 kilograms, with a range height between 8 kilometers and 30 kilometers. A lot of research is designed to give the military an expanded vision. Thus, the U.S. Army is testing integrated visual augmentation system glasses, which use facial recognition and can translate words, symbols, and road signs for soldiers. The glasses can project visual data from drones right in front of the soldier's eyes. It's expected to get widespread adoption in the mid-2020s. The U.S. Army is also finalizing trials of its Advanced Night Vision Binoculars (ENVG-B), which will allow soldiers to shoot accurately from the hip and around corners. It will also provide improved situational awareness, thermal imaging, and better depth perception. But most importantly, the device improves marksmanship by displaying the weapon's point of aim and can be linked to additional video or virtual feeds that give views from other positions and allow firing from around corners. According to the Army Times, U.S. soldiers based in South Korea are the first to use these new glasses. Another technology that the armies of countries such as the United States, Britain, and France are trying on is flying suits, satchels, and hoverboards. That is, anything that can help a soldier get from one point to another quickly through the air. For example, DARPA has announced a competition to create jetpacks, the Royal Navy is training with the inventor of the flying suit, Richard Browning, and the French president believes that Frank Zapata's flying board will one day be used in the French army. The current disadvantages of all the devices is that they are noisy and dangerous for the pilot when used in actual combat situations. Do you think flying suits will catch on in the military? Let us know down in the comments, like this video, and subscribe to the Pro Robots channel to stay up to date on future technology.